Okay, welcome to the second part of lesson 6. So we're just going to pick up with learning target 7, where we're going to describe the difference between periodic and non-periodic sinusoidal and non-sinusoidal. Also, one thing we're going to do here with this is talk about some of the key definitions, which we already started talking about in the last part. Note, a periodic function is a pattern that repeats itself, so it has to repeat itself exactly. The cycle of the graph, and really that's the way you know if it's periodic, is that it does have a cycle. It's the smallest complete repeating pattern of the graph. So it's a complete repeating pattern. The length of a cycle is called a period. If you can't determine what the period is, it's probably not periodic. We'll study a particular wave called sinusoidal. It's just really a perfect wave. It's a transformation of sine or cosine. And it really will look like, if you take the scale away, the sine and cosine curve, which really look the exact same. The axis of the curve is going to be the average value, so it's going to be the highest and the lowest. And we really just calculate it by finding the average of the two numbers. So let's look at a couple examples. And the amplitude, is that height of the wave above rest, above the axis. So we have a Ferris wheel that goes underground, and so this wave is called periodic and sinusoidal. It repeats itself and it's a perfect wave. This graph shows one cycle, the 360, one rotation of the Ferris wheel. The axis of the curve is 0, so the average height is 0, or just the y-axis. If you take the average of 10 and negative 10, the amplitude is 10. And so these are just key features of the application. If the Ferris wheel was moved up, things would change slightly. The graph would still show one cycle. The period's still 360. The axis curve is different. So the way we find the axis is we take the average of 21 and 1, which are the two heights, the maximum and the minimum. And so the average, the axis of the curve, really, which is where the wheel rotates around. So it goes above 11 and below 11. The amplitude is 10. That's the height above 11. A couple examples that we can look at. And so you notice how complex some of these get, because not often do they actually start on a nice value. And we will get to these in the next not the next lesson, but the lesson after. We're going to look at the equations of these. So first one that has a period, you got to go look at the period from something that makes sense. And so I see this point here and this point here, and I can read both of those. And so since I can read both of those, I'll take those points. The problem with taking this point and this point is they're all really hard to read from where it starts to repeat itself. But I know from max to max is good, or from min to min is good. So the period is actually the difference between 320 and 140, which is actually a nice period, 180. But it's not as easy to see elsewhere in the graph. The axis, similarly, is the average between the top 19 and 3. So the average between 19 and 3. I mean, you'd like to say it's 11, like it looks like 11. And so it should make sense that the middle line is 11. And the amplitude can be calculated. This isn't really a formula. It's just saying that calculated by finding the difference between the max or the min and the 11 line. So 8. You can also just count the points from 11 up. Period of the next one, 720. You can see that from the max to the max, 720. The axis is -5, so that's the average of the max and the min. And the amplitude, again, this isn't really a formula. It's just the difference between 13 and 5. You can also do the difference between -3 and -5, or +3 and -5. Or you just count from -5. We go up 8, and we go down 8 to the bottom. So that's not really a formula. You can find that out in many different ways. And the last one, the period looks like 90 degrees. You can argue that it's this one's a little bit funny. When we actually find the equation, we're going to assume that's right at 90. But just looking at this one, at 0, it's just above 3, and it's just above 3 at 90 as well. And so we're going to say the period's 90. The axis is 3, it's the middle line, y equals 3. And the amplitude is 0.5, so just a half above and a half below. You can really see that there are transformations here. Like if the period of the sine and cosine curve is 360, these have been changed. The axis is 0, these have been changed, and the amplitudes are 1, these have been changed. And so there are going to be transformations we're going to talk about. Okay.